kinds of junk. Here, let's do another example. Yeah. Example 13. Consider f of x equals to x squared plus 1, f1 of x rather, f2 of x equal to 2x plus 3, and f3 of x equal to 1. I claim that f1 of x, f2 of x, f3 of x, I'm my own worst cameraman. You guys are worrying I wouldn't notice. I'm worried I wouldn't notice. Not too much damage is done yet. Maybe I can edit that out. Maybe not. All right, so here's a basis I claim is a basis for polynomials of second order. So this is basis. Let me equal beta again. All right. Basis for P2R, right? So let's see, this is generically ax squared plus bx plus c, however you want to write it, right? Such that a, b, c are real numbers. So we can ask a slightly tougher question. We can ask, what's the coordinates, right? What's the coordinates of a generic vector in here? So this is where I've just raised the level of difficulty or significant. What's the coordinate vector of this guy? See, I need to figure out, the question is, what is, let's say, C1? So I need C1 times x squared plus 1, right? Plus C2 times 2x plus 3, plus C3 times 1, right? These things, whatever they are, oh, I'm sorry. Let me fix my jumping the gun here. So we need to figure out what linear combination gives us this. Then whatever that works out to, this would imply that ax squared plus bx plus c, the coordinate vector of that is c1, c2, c3. Now, what those are will require calculation in this case. Let's see here. So let me try to do it right quick. If I can, I can. If I can't, I'll cut and run. Let's see here. So this is x squared times c1. Ooh, that's nice. Plus x times 2c2 plus 1 times, c1 plus 3c2 plus c3. Actually, this is not that bad. So I can equate coefficients because remember 1x and x squared are linearly independent. So equating coefficients of this and that, right? And on the x squared, I get a is equal to c1, right? On the x, I get b is equal to 2c2. Well, this is very nice. So a is equal to c1. B is, I was about to make this homework. Man, I'm glad I didn't. Sorry. It's the small things. Let's see here, b over 2, c2, and then 1 gives me c is equal to c1 plus 3c2 plus c3, which in our current is a, plus 3b over 2 plus c3. So therefore, c3 is equal to c minus a minus 3b over 2. And what I have shown then is that in fact this coordinate vector is, it is a, b over 2, and c minus a minus 3b over 2. That's the coordinate vector of this guy. Because I figured out that choosing those for my coefficients gives me that linear combination back again. Now, in contrast, if I look at gamma as, say, 1x squared, right? and I ask what's the coordinate vector of ax squared plus bx plus c. Well, that's easier, right? Coordinate vector with respect to the gamma coordinate system would be just c, b, a. See, because the ordering matters. This, right, this guy is actually the same as c times 1 plus b times x plus a times x squared, right? Okay, well, I think I've said enough for today. I'm sorry I couldn't be in class with you guys. This came up at the last minute. I would have announced it earlier if I could have, but this just is what it is. So thank you for your patience. Hopefully I have everything in frame. Oh no! Well, I'll zoom out here and chill. So Friday we'll pick up with properties of the properties of the coordinate map, and trying to understand what is the structure of the basis for a vector space. How do you find the basis for a subspace? Questions like this is where we're going. So, thanks guys. Oh, and I might have a short quiz on this video. Thanks.